Good evening. Today we are going to see the analysis of doubly reinforced section, and that is for HYSD bars. Now this is most important table already we have seen, and that we have plotted from IS code page 70 figure 23A. By using that table, we have calculated total strain, which is elastic plus inelastic. Inelastic strain is given in the diagram, and elastic strain we have, that is stress divided by E. And stress we have this value, which will be calculated from this. Zero point 0.8 FYD is 0.87 FY. So already we are with this table. Now we have to, when we are going to solve this, you have seen that for mild steel, we are going to take this value as FSC 0.87 as FY, that we are going to assume. Now here we have to assume some value, and to assume this value we have to follow following steps. Now first we have to assume Ku assumed, we will go always 0.3. AST1, because we know, if you remember, we have Cu is equal to Tu, and Cu we have 0.36 FCK XU into B, and Tu we have 0.87 FY AST. And from this, we are going to take this formula 0.36 FCK XU, we have Ku into D into B divided by 0.87. So we have modified this formula. And now Ku actual we are going to take this as 0.3, and then we have next AST minus ASC. We know AST, we know ASC. We are going to calculate this value, and from all these values we are going to calculate actual what value of Ku we have to consider for first trial. That Ku we will get from here. And then once we know Ku value, that Ku value we will put in this Xu, which will give us value of Xu. And knowing this value of Xu, we can calculate epsilon S by using this formula 0.00351 minus dc upon Xu. And corresponding this epsilon SC, we are going to get value of FSC from the table, and that we have to consider as first trial. And if we will go with these steps, then generally we need not require to go for more than 2 trials. Most of the problems you can be with 1 trial only. So now we will go with 1 problem. So now we have this problem. So this is first. So a reinforced concrete beam of rectangular section 230 mm wide and 530 mm deep. It is provided with tension steel. This is given already 1570 mm square, and compression steel 1005 mm square. Effective cover is given 55 for both steel. That means we have effective cover on tension side and compression side. We have same, and most of the time we have this cover as same. And then we have to use M20 and Fe415. So now we have to first go, that is given data. So we have given data, that is value we have given B230, D475, FCK20, we have FY, that is 415, AST we have 1570 mm square. Now we are going to go for step 1, and in this step 1 we are with calculation of FSC. We have to assume value of FSC, and that we are going to find stress in steel, and this is whatever value we will get from this, that will be our first trial. So now we will assume Ku A is equal to 0.3, same steps whatever I have shown you. Then we have AST1. Now we will substitute value FCK, we have 0.35. So this is actually Ku assumed. And that value we have to take 0.3. Now we have 530. We have cover 55. So 530 minus 55, and from this we will get 475 mm, which will be value of D. And then that value we will have, and from which we will get AST 1544.66 millimeter square. AST minus ASC we have 1570 minus 1005 KU we will get from this. KU actual we know 0.3 into 565 upon 544.66. And from this we will get KU, which we have to consider for first trial, that is 0.31, and that should be less than, this is value of KU max for FE415. And now we know epsilon SC if we will put, now XU we will put KU into D, and substituting this value, we are going to get value of epsilon SC 0.00215. Now from this we have to calculate FSC. Now we have these values and our 0.00215, that will be in between these two values. Now we will have FSC, that is equal to, by interpolation, so 324.8 plus 342.8, so difference of this divided by difference of this into 0.00215 minus 0.00192, and from this we will get 333.25 Newton per mm square, and we will assume it as 333 Newton per mm square. Then by knowing these values, we will get value of XU, and that value of XU by substituting these values in the equation. So now we will put these values. 87,415,1570 minus 333. We have assumed this, and from this we will get XU 140.21 mm. Now epsilon SC we know. We have epsilon SC, that is 0.00351 minus DC upon XU, and we will substitute this value. And by substituting this value of epsilon XU, we are going to get value of FC. Now knowing value of FC, we are going to find out value of FSC. Then same formula. Now this is 0.00213, and for 0.00215 we have value 333.53 something. And so calculating this value by interpolation, we will get 333.23 Newton per mm square. Now assumed value and calculated value are very close, and therefore we will take FSC as 333.23 Newton per mm square. And now knowing this value, we will substitute in moment of resistance. We have, this will be mu1 and this will be mu2. Now mu1 we have in this cu1 into lever arm, and this is cu2 into lever arm. And then we will substitute the values, and from this we will get mr, that is equal to, so now these values we have substituted 0.36 FCK XU B in bracket D minus 0.42 XU plus FSC into ASC, and then we have D minus DC. And from this we will get values. First value, that is mu1, we have 99.62 into 10 raised to 6, and mu2 140.66 into 10 raised to 6, and that will gives me value 240.28 kilonewton meter. So now this value of moment of resistance of this section, we have 240.28 kilonewton meter. So likewise we have to solve this problem for Fe250. So today we will stop here only. The remaining part we will see, that is in the next lecture. So thank you.